So hello everyone. So I was there. My name is Dami. I was there last week, and for the array, uh, what's it called again? Yeah, but the question we have to solve on our own time. I tried to attempt some of them, but it was anyway. I don't know if I'm right with what I did, but I knew that last week class was very helpful, so everything is fine.
Okay, so one more person, then we start for today. Like, I just want to hear your feedback. We want to know that we are like we don't just want to always come like teach or talk. We want to know that this talk or whatever we say here is actually helpful, it's making impact. So that if there's any reason why we need to like change, or if there's anything we are not doing right, we need so that we want to definitely serve you better. So please feel free to just tell us whatever it is, like say anything. I didn't solve the question because they were too hard, or I tried the question, they were okay, or you guys are just doing rubbish here, you guys are not helping us. What Just say anything, like just say something, please.
Mic check. Can you all hear me?
Yeah, we can hear you.
My name is Grace. Just realized like this is the third in a series of this type of meetups where come together to solve algorithm questions.
Yes.
Yeah, so this is my first time and I'm really hoping to like I'm looking forward to what you guys are going to teach today. So
Oh, okay. Thank you, and thanks so much for joining. Okay, one last person. One last person. We have over 15 people on the call. Like like 3 people have talked. Yeah, we know. So like we need one more person. I think all the people that have spoken so far, ladies. I need a guy to like say something. Please. We know you're shy. Like just say something, please. Hell. Okay. Should I call names? Um, Sorry, forgive me if I don't like pronounce your name very well. But Botemi, yes, Botemi, please, can you say something? Like I want to hear from you. You can unmute and say something. Are you on this call? Okay. Let me assume this guy is not on this call.
Hope you sent a message on the chat.
Oh, okay. I couldn't see that. Oh, okay. Oh, okay. Let me just assume that later on you guys have something to say, even though I'm not really happy that nobody's saying anything right now. But it's fine. We'll just try our best. Okay, without further ado, we are going on to what we have for today. But as usual, before we start, please, a note of one, just okay, this time around it's not a plea, it is like something we need to do. Normally, like last week I said, we need to like always edit our names so that we can always identify the start level you have, like with the level of experience you have, because after like for now we are going to be having like 30 minutes of like run through or wrap up session about linked lists. Today, the topic we're going to be dealing with is linked list. We're going to be having a lead facilitator that is going to be taking us through linked lists, all about it. I mean, simple things you need to know, just very short, within 30 minutes. We already shared resources you could use. We already shared resources you could use online on our meetup. You can check that out, and we'll still send it via mail. And please, again, if you have friends or anybody that are having issues joining the call, please just tell them that all they need to do is sign in or create a Zoom account before clicking on the link. So like they should sign into the Zoom account or probably download the app if you're using your phone. If you're using your phone, you need to download the app first, sign in into the account, like create an account with it, then click on the link again. Like we had it, we need to do that. Sorry for the whole stress, but we needed to do that because of the issues we had last week. So if you're having anybody having challenges journey, just tell them to sign into a Zoom account. If you're using your laptop, you need to like sign into a Zoom account first. I don't know if you need to download it. I may already have the app, so I don't know. But whether phone, whether laptop, just download the app, sign into the Zoom account, then click on the link. It's very important. Yeah. So like if I continue, so last week we did beginners and intermediate level, but because of the experiences we had last week while in the room, yeah, sorry, I was saying something. I was saying that we're going to be having a 30 minutes wrap-up session of all about linked list. Then we're going to be splitting out. We'll be having like 1 hour breakout rooms where we'll be divided into smaller groups, and we are meant to solve 1 or 2 questions on linked lists. Yeah, so last week we did beginners and intermediate level because we wanted to regroup people according to their experience. So that I mean you are around people that are in almost the same technology experience with you, so there's no this lag or break in communication. But this week, please, we are going to be changing it. It's no more beginners and intermediates. Right now, we are going to be having 3 levels: level 0, level 1, and level 2. Level 0, I don't know, like I don't have any idea at all about algorithms, data structure. I'm just new into programming. I'm just new into all this stuff. I'm just new. Like I just started learning how to code. So all these things is like really new to me. That's level 0. So what you just need to do is, instead of P, B, or I, just append 0 to your name. Whatever your name is, put a dash, then 0. Whatever your name is, put a dash, then 0. Then for level 1, I know how to program. I know a bit about programming. I mean, I've been coding. I've been developing applications, whatever. But I'm quite new to algorithm and data structures. Like, because I mean, programming is something, developing application is something, developing mobile apps, websites is something, and knowing about algorithm and data structure is actually another thing. So if you are new about algorithm and data structures, linked list is like new to you, you've not really heard of it, or probably you heard of it, but you heard this faintly, maybe in a class or something, then you are probably in level 1. Then level 2 will now be the real intermediate level where, yeah, I've heard about it, I have some experience, I have little experience about it, I've solved some questions on it. That's level 2. So please take notes. Append your name with 0, 1, or 2. 0, you don't have any experience. Like, you just started programming, basically. You just entered this field, or you just started building applications. You know just about for loops, if statements, control structures. Like, that is where you are. No problem. Level 0. Level 1, I know about all these things. I know the basic principles. I know so much I know objects, I know loops, I know all these things. I know, but like I'm new to algorithm and data structures. Sorry, please mute your mics if you're not talking, please. Thank you. Yeah. So level 1, you are new to algorithm and data structures. Then level 2, you know so much about it, or you have an idea about it, you've solved some questions. Level 2. So please, let's begin to do that, because while the facilitator is going to be taking the stage now to do a quick wrap up or run through about linked lists, we'll be trying to group people or divide people into breakout rooms. And then if you don't have that appended to your name, it will be difficult for us to place you in a room. So please append 01 or 2 to your name according to your stack level, as I've explained. I'm going to re-explain it on the chat session so that you can do that accordingly. Please do that while the session is going on. Please and please and please do that. It's very easy to do that. You just go to your name. You can click on participants, or I think you can just go to your name icon on this place and then click on rename. I don't know. Let me share my screen if you want to see. Yeah. We are running out of time, but okay, yeah, basically it's just okay. I don't know if you can see my screen. I think I should just stop sharing. Okay. I don't know. I don't know. I couldn't show that. But it's just basically you click on your name either by through the participant session or whatever, wherever it is, like on these old tiles of names and all. Just click on your name and then click rename. Then rename it accordingly. So please let's do that. And without wasting so much time, we're going to be having the facilitator for today. He's going to be talking about linked list. He's going to be introducing himself when he comes. Yeah. Nonso, are you on the call?
Yeah, I'm here.
Okay, yeah. So please, let's welcome Nonso. Nonso, you can take the stage and 30 minutes. Time start now. Thank you so much.
All right. Good evening, everyone. I hope you guys can hear me.
Yes, we can hear you.
That might be just you. I don't know if others can.
Yeah, I can hear you.
All right. So last week, DG took us on arrays and strings, and this week we're going to be talking about a similar data structure, linked lists. So sure, let me share my screen. Yeah, can you all see this?
Yeah, we can.
I just did something. Can you still see it? And there's nothing blocking.
Yes.
All right. So my name is Nonso. Currently develop solutions using Node, the backend framework. Most of you might know. And what exactly are linked lists? So before I carry on, I'll need to know if everyone is following, please.
I'm following.
All right. So linked lists are just like arrays, in the sense that arrays are contiguous blocks of elements. Yeah, like we have an array of 1, 2, 3, 4, and then to index the fifth or sixth element, you just indexes like array brackets for, or how we are shown in the last class, if you can remember. If you can't, you have to brush up on it to understand. And that's just it, yeah. But for linked lists, they are made up of nodes. They are stuff we call nodes, yeah. So this right here is a node where we have this data and stuff. For instance, here, A is the data, A is the data, and it has a pointer to the next node. That's how linked lists are structured. They're made up of nodes, with each node having a data and a pointer to the next node. So in this case, we have A, we have this node containing a value or data A, and a pointer to the next node B. B also is a node containing a data or value B, and has a pointer to the next node. So that's how it goes on until the last node, which is called the tail, having a pointer to nothing, it doesn't point to anything. So when dealing with linked lists, yeah, normally the user or the programmer only has access to the first node, that's the head. It doesn't have access to any other part of the linked list because it is a whole structure, it is a long list, right? But the programmer only has access to the first node, which is called the head. We call it the head. And in some cases, he might have access to the last node, in this case D, which is called the tail. So at most, what you can have access to is the first and last node, right? But usually, in most cases, you're always having access to just the first node, which is the head. So remember I said each node has a pointer and a data value. Now this data value is the actual, like this node is like a container. So this value is the actual like value of the node. So for instance, our head node, which is node A, has the data value of A and has just one pointer to the next node. So if you have access to A, that's the head node, which you always have access to, right? If you have access to A, you cannot go to C from A. You only have a pointer to B. So to get to C, you must go to B first and then visit C. To get to D, you must run through B, C before you get to D. You can't jump between nodes, and that's why it's called a linear data structure. It just goes linearly, like in a straight line. You can't go from B to D or from A to C. You have to access them linearly. So A points to B points to C, and C points to D. I hope that's clear. So the bullet points, I've explained them. Linked lists, the linked list is made up of nodes, right? You can have 5 nodes, you can have 10 nodes, you can have 100 nodes, but you only have access to the first node, right? Now, each node has a value and a pointer to the next node. So if I have you have access to the first node, which is the head, and in this case, it's one with a data of A. So if I have access to the first node A, it means I only have access to B from A. If I want to access C, I have to go to B first and then have access to C from B. You get? And the first node is called the head, the last node is called the tail. And in this case, our last node is the one with the data D. So I hope that's clear. I'll move on to the next slide. Um, in order to understand linked lists or to have an idea of what they look like in memory, think of trains. You know how we have electric trains or even locomotive engines where like coaches are attached to each other. Like you have the head of the train, and then the train is that particular coach is attached to another coach, and that coach is attached to another coach. So if you are inside the train, you can't go to the last coach without passing through all the coaches in the middle. Do you get? So that's how linked lists work in real life. So imagine a case of dominoes. I don't know if you know dominoes, but they're like stacked up chips that have this influence of touching one another when the first one is pushed. So if you touch the middle part of the domino and push it, it only affects every other domino after it. So in order to affect all dominoes, you have to start from the head, which you have access to. So when you push the head, it's like touches every other domino in the stack of list. In the sense that you have a playlist. Let's say you have a playlist of hip hop songs, and then to visit the next song in the playlist, you just like click next, right? But if you are on a song, let's say your playlist goes like when you press next, you go from A to B. You press next again, you go from B to C. You can't jump like songs, right? For you to go to another like a song you want further up in the playlist, you have to like go through it linearly. You have to go from this first song to the next song to another song before you get the song you're looking for, right? So that's how it works too. And if you want to visit former nodes and former songs in the playlist, you have to go like you have to use the previous button. You can't jump songs. So those are like applications in the real life scenario of linked lists. And I'm going to try and use arrays to explain linked lists. So you can see that every data structure has like influence on another data structures. So that's why we can't just like read and forget or understand and forget. We have to visit them from time to time. So based on our last class, like we were taught arrays, and we saw that you could access a value k in all of one time. All of one time meaning constant time. you don't need to know other parts of the array to get what you want. So in this case now, I know this is a little bit unclear, but you have to squint a little bit. In this case where we have an array of 10 elements from 0 to 9, if we want to access the elements or the fourth element in the array, you know our indexing always starts from 0. So if you want to access the fourth element in the array, you have to go from, you have to just put the index, that is 3, because I want to fetch the value on 3. I just say A brackets 3, in this case k is 3, right? So I access 3. I don't need to know the values of 2 or 1 or 0 or anything after 3. Once I just have this index, which is 3, I can get the value that is stored in 3. And that is constant time. It's not dependent on the number of elements in the array or how large or small the array is. It's just at once, like that fast. You have the index, you access it. Now, if you don't have the index in an array, it means for you to know what value is stored in 3, you have to go through everything. So I say, this value I'm looking for, is it what is stored in 0? Nope, I move to 1. Is it what is stored in 1? Nope, I move to 2. Is it what is stored in 2? Nope, I move to 3. Is it what is stored in 3? Yes, what I'm looking for is stored in 3, so I know that yes, this is 3. But that is because I don't have an index. And if I don't have an index, why are we using arrays? Because that is the advantage arrays give us, random access. Did you explain it? We have the particular index to that array, to that element in the array rather. Now for linked lists, it's a little bit different. Remember, in linked lists, we're not dealing with indices rather. We only know a particular, we only have access to a particular node, which is the head node. Remember I told you. And to access a particular element in the whole linked list data structure, we have to start from this head node, being this first one. Start from this head node, check the next guy, because that head node has a pointer to the next guy, right? So we check the next guy. If the next guy is what we're looking for, we take it. If it's not, we check the next guy. If the next guy is what we're looking for, we take it. If it's not, we check the next guy. If it's what we're looking for, we take it. If it's not, we check the next guy all the way up until the end of the list. So peradventure, what we're looking for is not in this list. We would have run through all the elements in this list. That's the worst case scenario. So that is an O of n time because we visited every single element in the list. I hope you understand. So that's the whole accessing of our elements in the linked list. That's how it works. You have to start from the head because that is the only node you are given. You're just giving this head and no other node. So you have to start from there and continue clicking like next to get to the next node. You get. So if I'm looking for a node that's here in this case, that's the second to the last element, I have to start from the head and go all the way until I get that particular node. And that's just the that's the disadvantage of linked lists over arrays. But if linked lists have disadvantages, why are we using them? You'll get to know later on when I'll explain the advantages that linked lists has over arrays. So linked lists have types, right? We have the everything I showed is still based on nodes and their data and a pointer to the next node. It's still the same structure. So let's look at single linked lists. This is a type of linked list where it's basically the same thing I've been explaining so far. There's no difference. Like each node just has a pointer to the next node. So if I'm at the first node, which is the head node, I have a pointer to B. If I'm at the second node, which is B, and obviously I must have gotten here from the first node because I just can't land on B since I only have access to the first node. So if I'm on the node B, I have access to just the next node, which is C. I cannot go back to A because B doesn't have a pointer to A, right? It is just in one direction. It is a one-way street. You come from the head node. When you visit the next node, you don't have access to the head node anymore, right? You are on the node you visited most recently. I don't know if you understand. Let me go over it again. So remember, we only have access to the head node, right? And the head node contains a pointer to just one node. As we can see here, it contains its data, which is A. That's the value we store in the actual node, because remember, the nodes are just containers. Now, that value A is contained in that like node, and then the node also contains a pointer to the next node only. It doesn't point to any other node. So from this head node, we point to the next node B, right? And when we are on B, we cannot go back to the previous node because remember, in singly linked lists, each node has just a data and a pointer to the next node, right? So when we are on B, we can only move to C and nowhere else. So when we are on B, we can do two things. We can have the value of B, which is B itself, and we can move to the next node, which is C. Those are the only two things we can do on that particular node. When we are on C2, it is the same thing for singly linked lists. We can move to the next node, which is D, and we can have the value of C, right? So it is a one-way street, you can't go back. And the last node, which is the tail node, points to nothing. Remember I said we can't move back, like we can't backtrack in a singly linked list, right? Any node we are on, we can only go forward from there or check the value of that node. So at this point, I can check the value of D and I can't go back to C because D doesn't have a pointer to C. D only has a pointer to null. So when a node points to null, when it points to nothing, it means that node is the last node or the tail. Do you get? So when it points to nothing, it means that node is the last node and that's it. We've gotten to the end of the linked list. So in order to start from the head of the linked list again, or in order to visit any other element in the linked list, we have to go back to our initial pointer, which is the head. Remember, we have that head as access. So we can't lose that head because if you lose that head, you can't access any other node in the linked list. So having that head means we start from that like head again and access any other person or any other node you want to have access to, right? And remember, when you land on a particular node, you can't go back and you can only move forward from a particular node to just the next node. That's how singly linked lists work. It's a one-way street. Just remember that. And we have some examples here. Dominoes, like I explained earlier on. So I don't know if this GIF is playing, or if it is, we can see that each domino has access to just the next node. Once a domino falls, you can't go back to it. It's just moving one way. So that's how the single linked list is implemented in like real life applications. And we can see a conga line. I don't know if most of us know this dance where they dance in like a straight line holding each other. So let's say this woman on green and a blue jacket is the head, right? So she's holding the next node, which is the next woman on yellow. And to move to the woman on yellow, you just use her hand, which is the pointer, to go to the woman on yellow. And when you're on the woman on yellow, you can't move backwards, right? Because the woman on yellow is just pointing to the man on blue. So to move from the woman on yellow to the man on blue, you just follow her hand, which is the pointer. And when you're on the man on blue, you can't go back to the woman on yellow because you've left her. It's a one-way street. You get, it's only pointing to the next person. That's how you move from this man to this woman, and then from this woman to the last man. And the last man is pointing to nothing. He's holding nobody. So he's the tail node. Do you get? He's the tail. It doesn't point to anyone. So in this scenario, the conga line is a singly linked list, right? So note that that's how singly linked lists work. And the next type of linked list we have are doubly linked lists. Yeah. Doubly linked lists or a doubly linked list is a linked list in which every node has a pointer to the next node and a pointer to the previous node, right? Except the head and the tail nodes. Let me come again. In doubly linked lists, each node in the linked list has a pointer to the next node, right? And a pointer to the previous node, except the head and the tail nodes. So remember in the singly linked list, as we can see here, it's still here for us to see. We have access to just the head node, right? That's what the programmer has access to. Now to visit item 3, right, I have to go to 7 and then go to 3. And when I'm on 3, you can see 3 doesn't have a pointer to 7 anymore. So I can't go back, I can't backtrack, right? I can only go forward or stay on 3. Do you get? That's how singly linked lists work. Now, for doubly linked lists, I have access to the first node, which is 5, right? And I also have, I have access to the first node, which is 5, and I can visit the previous node and the next node, right? Now, in this case, we can see in the W linked list over here that 5 points to 7, right, as the next node, and 5 points to null as the previous node, right? 5 points to null because 5 is the head. It is the first node in the whole linked list structure. So it doesn't point to anything before it, right? It only points to the next node. That's what I explained earlier when I said each node, apart from the head and the tail nodes, have pointer to 2 nodes, right? The head can't point to 2 nodes because it's pointing to just nodes after it. Since it's the first node, it can't point to anything before it. So that's how the head works, right? It has a pointer to the first node and a pointer to nothing as the previous node, right? It has a pointer to the next node and it points to nothing as the previous node. So in our doubly linked list, 5 points to 7 and 5 previously points to nothing. When we move to 7 from 5, obviously, as I've said, because the only way to get to 7 is from 5, right? So now we are on 7, which is a node. We can move to 3, or we can go back to 5. You see, that's the difference between the double linked list and the single linked list. In the single linked list, when we are on 7, as we can see here, which we got to from 5, because there is no other way to get to 7 since it's not the head. When we are on 7, we cannot move back to 5 in a single linked list. We can only move to 3, and from 3, we cannot move to 7, we can only move to 4, right? That's how single linked lists work. But now in double linked lists, when we are on 7, we can move to 5. As you can see the arrow pointing down here. I hope this stuff is not coming. As you can see the arrow pointing down here, 7 moves to 5 and 5 moves to 7, right? 5 can go to 7 and 5 cannot go to any other thing before it because 5 is the first node. 7 can go to 3 and 7 can go back to 5 because it is a doubly linked list. It has a pointer to the next and the previous node, right? When we go to 3 from 7, we can go back to 7 and we can go to 4, which is the next and the previous node. So we have access to the next node, the previous node, and we can choose to stay on that node, which is 3, right? So in this case, we can choose to stay on 3, or we can go to 4, or we can go back to 7. And if we choose to go back to 7, we can choose from 7 to go back to 3, or to go back one step again to 5, right? So that's how doubly linked lists work. And at the end of the day, we arrive on at our tail node, and our tail node points to nothing. It doesn't point to any other node because remember, it is the last node, right? But it points to a previous node, meaning when we've arrived at the end of our linked list, we can go all the way back to our head node in the double linked list because each node has a pointer to the previous node, right? It's kind of a way of saving the stress of having only access to the head and then have to go back to the head again if you want to access a value or a node in the middle. That's going to be stressful. So for double linked list, you have access to the previous node, the next node, and the null node. Sorry, and the value itself. Right. So I'm going to teach you the
Please, everybody, kindly unmute your mics.
Okay, so as I was saying,
sorry, kindly mute your mic. Sorry for that. I mean, kindly mute your mic so that you don't interfere into what the speaker is saying. And sorry, no. So please, once again, append 0, 1, or 2 to your name according to your levels. I'm going to be dropping the listing on the chat again, so you can look through the chat to understand what I mean. Okay, no, so sorry, you can continue.
All right. So as I was saying, right, the advantage of doubly linked lists over singly linked lists is the fact that we can move forward and we can move backward. In single linked lists, we can just go forward, right? So that's that. And examples are trains. In this picture here, we can see this train from the first that's where the I don't know what they call them, the captain of the train or the pilot or whatever, or whoever is moving the train, right? We can start from where he is, which is the head, visit the next coach, right? Visit another coach, right? And we also have access to the previous coach, right? So we can, even if we're at the last coach, we can go all the way back to the head coach, right? So trains are examples of doubly linked lists, yeah? And when we are on the last coach, we can't like go to any other coach because that coach is the tail node, right? It's called the tail, and it points to nothing, right? In this example of people holding each other, we can see that the orange guy is the head node and he doesn't hold anybody before him, so he points to nothing previously. But his next node points to a yellow guy, and the yellow guy has access to the previous guy, which is the orange guy, and the yellow guy also has access to the next guy, which is the green guy. So that's the whole scenario for doubly linked lists. That's the difference, right? So I hope we've covered that. And for secular linked lists, um, this is going to be a little bit confusing, but chill. Secular linked lists are just doubly or singly linked lists in which the last node, which is the tail node, points to the head node. Let me go again. Secular linked lists, right, are linked lists in which the last node, which is the tail node, points to the head node. So if we look at this, remember, they can be singly or doubly. You can have singly secular linked lists, and we can have doubly secular linked lists. Yeah, this means that for singly secular linked lists, right, every node has a pointer to just the next node, right? But the tail node doesn't point to nothing anymore. In singly linked list, in regular singly linked list, right? Remember, the tail node points to nothing because that is the end of the list. But in singly secular linked lists, there is no end, right? It is a rotation. The last node, which in this case is this item n, right, has a pointer to the first node, but it doesn't have a pointer to the previous node. That is why it is a singly secular linked list. Do you get? So in this scenario now, I can start from the head, right? And we'll be given the head, right? We'll always be given the head in linked lists. So the head is this item 1, and from the head, which is item 1, I can move to item 2, and from item 2, I can move to item 3. Remember, when I'm at item 2, I cannot go back to item 1 because it is a singly secular linked list, right? It is singly before it is secular. Three, I can go to item 4, and this tail node in question points all the way back to item 1, which is the first node. Sorry, I'm getting a message. My internet connection is unstable. Can you all hear me, please? I will still need the verification. Can you hear me?
Yes, we can hear you.
Okay.
Yes, I can hear.
So what's the difference between a singly and secular linked list now? This difference is the fact that in regular singly linked lists, the last item can point to the first item. Sorry, in regular singly linked lists rather, the last item, which is the tail, cannot point to any other node. It is the last item, we stop there and it points to nothing. But in singly secular linked lists, the last item points all the way back to the first item, which is the head. That's that for singly secular linked lists. And now for doubly secular linked lists, the last item, which is the item n, points all the way back to the first item, which is item n, which is item 1, right? Now, if a linked list is secular, it just means the last item, which is the tail, points back to the head, right? It is secular. There is no body pointing to a null value. There is no body pointing to nothing. Whenever I'm at any node, I am always pointing to another node. The difference between a singly secular linked list and a doubly secular linked list is also the difference between a singly linked list and a doubly linked list, which is the fact that every node has a pointer to the next node and the previous node. I hope you get that. I don't know how to explain this much more. In secular linked lists, the last node, which is the tail, points to the head, right? If the secular linked list is a singly linked list, it just means you can only move one way. If the secular linked list is a doubly linked list, it means you can move forward and you can visit your previous node. That's just what it means. And this is an example, a group of people holding hands together. So we can see, let's say the head is this guy, that's this guy the red dot is on. So I can move from the head, right, all the way to the next guy in the um, array, right? And I can move from this next guy to the next guy in the list, and I can move from this guy all the way to this guy, and I'll go all the way and still arrive at my head. Also, I can move from my head to my tail, which is this guy, and go all the way until I arrive right here. This example right here, I couldn't find it. So basically, we have these are what I could think of. I think there are more actually, but the basic operations we have on linked lists are insertion, deletion, searching, and traversal. I'll explain what those four mean. You might need to get a pen and paper because I didn't write like stuff concerning this. So for insertion, what it means is I have the head, right? I'm still explaining insertion, mind you. So let me go back to the singly linked lists. I'm going to be using singly linked lists to explain insertion. So insertion wise, we are at the head node, right? Remember, that's only what we have access to, right? And let's say I have node A, B, C, and D, right, in this linked list, but I only have access to node A, and I want to insert a node. Let's call this node as insert 5, right? I know this is a list, this is a linked list of letters, but let's say I want to insert a number, and I want to insert 5 at the end, right? Now, what this means is, remember, I don't have access to any other node. I just have access to A, which is the head node. If I want to insert a node, it means I have to start from A, right? Look for the last node, and then append what I want to insert to it, right? So let's say I want to insert 5. I start from the head, which is A, visit B. Remember, I cannot jump B, C, D. I have to visit B. B still has a pointer to a node, so I visit C. C still has a pointer to a node, I visit D. D doesn't have a pointer to any node, it points to nothing. So it means at D I can insert 5, right? So it's more like appending 5, right? So I just append 5 to this value here, D5, right? I don't know if you need me to kind of illustrate this. So sorry. Give me 2 seconds. So okay, so let's say in this scenario we have A points to B, right? B points to C, right? C points to D, and D points to nothing, right? Now in this scenario, if I want to insert 5, you know, I only have access to A, right? So let's say my head is equal to A, right? I only have access to A. It means I have to start from A, that's this value, right? Move to B, which is this value, move to C rather, which is this value, move to D, because C still points to a node, right, which is this value, and D doesn't point to anything. It means I have gotten to the end of my node, and I insert what I want to put in, which is 5, right? You get it? That's if I wanted to insert 5. If I wanted to insert E, it means I'm appending E to this linked list. Do you get? So now, the advantage of this is, if we are going to have to start from the head, right, which we only have access to, and move all the way to E to D, which is the last node, it means it's going to take me what? Constant time to append E, right? I'm not counting the amount of time it takes for us to look for the part where we're going to insert what we want to insert. I'll come again later on. But let's imagine we want to insert, let's imagine this linked list contains A, B, C, E, and I want to insert D, right? I want to insert the letter D. So let's say what I want to insert is D, right? Now, for me to insert D, I want to insert D between C and E, right? I don't want to go to the end because it doesn't look okay to me. Like D should come before E and after C, right? So what I'll do, having only access to the head node, is that I'll start from A, move to B, right? Move to C, right? And then I would insert D before E, right? I'm going to insert D somewhere here. I don't want to insert D after E. So what I'll do is I'll say C's next node, right? I'll point C's next node to D and point D's next node to E. And as you've seen, I've inserted D between C and E, right? So if I'm going to count how much time it took me to insert D, not counting the fact that I have to look for where to insert it, right? Because having access to the first node, which is the head, means I have to look for where to insert D before making that insertion. I'm not going to count the time I'm going to use to look for like a particular place or space to insert D. It's going to take me constant time to insert that element because it means I'm already here and I just want to insert that D into it, right? So that's it. I know it's a little hanky-panky, but you have to like read further and understand it. So that's how insertion works in linked lists. Yeah. If I'm not counting the time it took me to look for the particular node, that means I'm going to insert in constant time. But if I'm going to count the time it took me to look for the particular node, it means my time complexity is going to be O of n because I have to look for it. And peradventure that node that I'm looking for, let's say I wanted to insert at the end, right? Let's say that node I'm looking for is E. It means I have to go through everybody in the linked list, which is n, because the linked list is of length n, right? So it means I have to visit everybody and then insert that particular node. So basically, where linked lists have an advantage, remember I said I was going to tell you, where linked lists have an advantage over arrays is this insertion time, right? Because to insert in an array, it means you have to like, I'm not counting access time for arrays now, right? Let's say you have that spot, right? To insert into that spot, you have to shift everybody from that particular element backwards so you can create space for what you want to insert, which is O of n. When linked lists, you don't need to shift anybody. What you just do is to insert this D, I simply point C to D and then point D to E, right? That's how insertion works. So basically, if I'm not looking for anything, insertion is O of 1, right? So that's for insertion. And for deletion, so the next thing I was going to talk about was deletion, right? For deletion, it's basically the same thing. So to delete to delete an element from a linked list, what it means is, let's take for instance now our delete guy is B or C. Let's say C. Okay, sorry about that. So let's say I want to delete C from this whole linked list. Yeah, I want to delete C. What it means is I have to look for C first, right? Because I don't know what C is. I don't know where C is, rather. I only have access to what? The head node. Remember that at all times. So having access to the head node means I start from A, I visit A.next, that's the next guy, the person or the node A is pointing to, which is B, right? So I visit B from A, and it means I'm on B at the moment, right? B is not what I want to delete. I want to delete C. So I visit B's next, which is C, right? And wow, look, C is actually what we are looking for. So to delete C, what I simply do is I point B to D, right? I just point, I take B is next, right? Whatever B is pointing to, which was C, B was pointing to C initially, and I don't want C in my list anymore. I just take this pointer, right, and point it to D. Do you get? So if I take this pointer B, this B's pointer, and I point it to D, it means nobody's pointing to C anymore. So C is no more in this list. So I've successfully deleted C, right? So that's how deletion works in linked lists. Remember, I'm using single linked lists. This will be different for like other types of linked lists which you have to read up on. So so for deletion in this now, what will be the constant time, right? Let's analyze it. What will be the runtime rather? Now, looking at this, it means if I have access to the first node, right? And let's say we still have C there, and I still want to delete C. If I have access to the first node, I have to first look for C, right? And if C is the last node in this whole linked list, let's say what I wanted to delete was E, which is the last thing in the linked list. It means I have to go all the way to the end. So looking for what to delete in that list is actually O of n, where n is the number of elements in the list, right? It means I have to start from the beginning and go all the way to the end if my element to delete is at the end. That's the worst case scenario. So I have to touch everybody, worst case, right? So looking for what to delete takes O of n time alone, right? And then actually deleting, let's say I found what to delete. In this case, I wanted to delete C. I start at A, I move all the way to C, right? I start at A, I move all the way to C. I have seen what I wanted to delete, which took me O of n time. Now, actually deleting this just means what? I'm pointing B to D, right? I'm going to point B to C's next, which is D, and that is constant time, right? So deleting, again, if I'm going to have to look for what to delete, which obviously I have to, right? Because to look for what to delete, you have to first look for like whatever you want. I can't tell you delete D from the linked list and then you just have arrive on D. It's not possible because you only have access to A. You have to look for D in that linked list, which is going to take you O of n. And then to delete is actually what? To do the actual deletion, which is just pointing B's next to C's next. To remove C from the list is going to take what? O of 1. That's constant time, right? And normally, when we have a runtime like this, we just pick what's the highest because drop the, I've forgotten what Timmy called it in his class. I think it's drop the irrelevant or drop something. But you drop the guy that doesn't have too much effect on the runtime, right? So I'm dropping O of 1 and it's O of n because I have to look for the particular element first before I delete, right? Even if I'm going to delete the element at the end, I have to go all the way to the end, which is O of n, and then delete. You get? So that is that. So the runtime actually varies, right? For all this, the runtime varies. And then for searching, we have searching. Searching means I have a linked list and I'm looking for a particular element. So let's say the search value I'm looking for is A. Let's use something very like obvious, right? Now look at this scenario. If I'm to search for A, my head is already A. So I don't actually have to go all the way to the end of the list, right? It means in this problem case, right? My search took me constant time because my head is A. Just a search for A. Oh, my head is already A. Just return my head and say yes, this is the head of the linked list, which is A, and that's what you're looking for. So in this case, it took us O of 1, right? It took us constant time, which makes sense because it's the first value and we already have access to it. But let's say we're searching for E, right? Because obviously, if you are looking at problems, when you want to solve problems, you have to pick a scenario where the worst case is possible, right? You have to always look at the worst case. We don't want to say this is the best time it can run. We have to look at the worst time it's going to take us to run. So which is when I'm searching for E. And if you're searching for a value that is in the last element for a linear data structure, it means you have to start from the beginning and go all the way to the end because it means I'm going to start from here. Considering the fact that I already have access to A, I also have to check if A is what I'm looking for. It is not. I move to B. Is B what I'm looking for? It is not because I'm looking for E. I move to C. Is C what I'm looking for? It is not. I move to D. Is D what I'm looking for? It is not. I move to E. Is E what I'm looking for? Yes, it is. It means I have found my search value. And look what this took us. It took us all the way to the end of the list. So it means searching in the linked list is going to be what? O of n, because we have to visit everybody in the list. I hope you understood that. And for traversal and searching are similar, but they mean different things. Yeah. Traversal means you want to travel, right? I want to visit everybody in the list. Let's say, imagine you have a linked list and you want to know all the elements that are in that linked list. It means we are traversing the linked list, right? It means we start from A and visit everybody in the linked list because we want to know everybody that is contained in that linked list. For searching means we are looking for something, right? So we are looking for E. If there was a way to know what E is without or if there was a way to know where E is without visiting everybody in the list, I will do that, right? I don't need to visit everybody in the list. Because if, like, I'm looking for E, why do I need to visit everybody in the list if I can just have E? But for linked list, we have to visit everybody because that's the only time we'll know that E is not equal to any of these other guys, but just this last guy, right? So in terms of traversal, we are visiting everybody in the list. It is a must. So traversal is also going to take O of n because we are visiting everybody in the list. Do you get? Now, I don't know if I was a little bit confusing initially, so I'll just like go over them quickly, like as quick as possible. Insertion, I want to insert into like a list. If I have the position, let's say I want to insert a value at position F, I am not going to count the time it took me to get to F, right? Or the time it took me to get to the end of the list, to insert at the end of the list. Because to insert in any data structure, you actually have to look for that position, except non-linear data structures, which will be touched later on. So to look for that position in which you have to insert is going to take O of n, right? But I'm not counting that. It's called the access time. I'm not counting that. I'm just going to count the time it took me to do the actual inserting, right? And now to do the actual inserting means I just have to point the previous value to the value I want to insert, and that's all. So you want to insert F, I'm just pointing E to F. So that's O of 1. It's constant time, right? If I want to insert C, if I want to insert something between C and D, that's at this position, I'm not going to count the time it took me to get from A to C, right? I'm not counting that. If you want to count that, fine, it's O of n, but I'm not counting that. The time it's going to take me to insert means I'm just pointing C to the new value I want to insert, and I'm pointing that new values next to D. So if I'm going to insert something like 0, I'm going to point C to 0, and I'm going to point 0 to D, and I've inserted 0 between C and D. COD. So that's what it means, right? So that's just all like for insertion. And then for deletion, it's O of n because to delete, you have to know what you want to delete. So you have to search first and then delete, right? So for deletion, if I want to delete E, I have to search for E first, and that's going to take me O of n to search for E, and then delete E. So the actual deletion is going to take O of 1, but I have to search for that value first, right? So I search for E, I see E, I delete E. So O of 1 plus O of n for searching is going to take me O of n in total. And for searching, like I said, I'm looking for the particular value. I have to check if everybody is equal to the particular value. If I'm looking for D, I start from A. Is A equal to D? No. Is B equal to D? No. Is C equal to D? No. Is 0 equal to D? No. Is D equal to D? Yes. And I return D as the value. So that's how much it took me to search. But time has gone. And for traversal, I'm basically visiting everybody. So if I want to print everybody in the list, I start from A, B, C, all the way to F, and I've visited everybody in the list. That's traversal. I always have to visit everybody in the list for traversal. So I hope you understand that. So those are like the 4 basic operations we can carry out on linked lists. So that's for that. And I'm going to go back to sharing. And so I think that's the end of the lecture. Is there any other thing? No. So you can reach me out on Slack as James Okole. I'll be available to answer any questions you might have. Thank you. Hope over to you.
Okay, so thank you very much. That was quite a bit. That was awesome. And yeah, we've not so much time. So please, I know you guys may have questions, but if you have any question, you can feel free to drop it on the chat session. You can message him privately, or you can drop it, let everybody see it. You can message him on Slack also. We don't have so much time to take questions now. But if we are back from the breakout rooms and we still have some time, so we can take questions then, or possibly when you get to your breakout room, there'll be other facilitators there, like there'll be a facilitator there, so you can also throw out any question you have to them there if you have any questions. So without further ado, yeah, without wasting so much time, we'll be going back to I think we are currently being grouped into breakout rooms based on
Sorry,
what we indicated. Yeah.
sorry. I want to make a correction. Sorry, Opa just corrected me on something. Sorry guys, for insertion, right? I wasn't counting the access time, remember? So it was O of 1. And for deletion, we shouldn't also count the access time because remember, we are just moving to look for what to delete. So deletion is also O of 1. Sorry guys, sorry. You have to correct that. If you're not counting access time for insertion, it is O of 1. If we're not counting access time for deletion, it is O of 1. If we're counting access time, they are both O of n. Sorry, please no stats. Thank you.
Yeah, thank you, Nancy. Yeah, so just as I was saying, we are currently being grouped based on what we indicated. And if you have not done that, please indicate, append, just click on rename on your name and try to append 0, 1, or 2 to your name according to your experience level. 0, I have little or no experience in programming. I mean, I'm just hearing about for loop, I'm just hearing about all the stores, I'm just hearing about transfers for the first time. 0, that's level 0. 1, I'm new to algorithm and data structures. I mean, I know a bit, but it's very small or something. 2, I've been doing this for a while and I can solve some questions. So boom, please, let's do that if you have not done that, because if we are going to be splitting into breakout rooms now and you don't have this appended to your name, you would not be grouped and you will still remain on this room. Then maybe the admin would know what to do or something. So I think Joda, you can send us to our breakout rooms now. And we have wasted so much time, so we really don't have up to 1 hour again to spend in breakout rooms. Yeah, I think
Yeah,
we
so I've
can.
already grouped everyone. I think there should be a button. So okay, let me open the rooms. Can everybody see the
Yeah,
break?
yeah, you should be able to see your breakout room now. Then just click join to the room and go to your rooms. Yeah, sorry, I don't know. I'm trying to call on Joda so that he would, because he's the one that, like, he's currently like the host, so he's the only one that can assign to.
Oh, okay. All right, no problem.
Yeah, I'm trying to call him to come to the mirror.
When did they start solving the questions? How long has it been?
That we just started basically now.
Okay.
Yeah, I'm going to talk to him. It's coming up.
So for my
What happened? Yes, ma. Hope. What's up? Essex, yeah, here. Essex, I have a group for you at this point.
yeah, I'm here.
Will you join
What
level?
group are you adding me to first?
Eh?
What group are you going to add me to? Intermediate or beginner?
It's only so all the groups I put two people in them, and all the groups are already full except for beginner. So will you join Hope in beginner?
Except for what?
Beginner, the beginner level. Remember we now have
Oh,
three
okay,
groups.
yeah, you can add me to the beginner. It's fine.
Yeah. This is an absolute beginner, like
Oh, they know nothing at all.
Yeah.
Okay.
Yeah, I'll add you there now. All right, thanks.
No problem.
How do they used to add again on this thing? Okay, can't find the button to add.
Hello.
Yeah, hi, I can hear you.
Okay.
Are you beginner, intermediate, or advanced? Or what was it again? I can't remember how they broke it down. There are 3 levels basically. Do you know about the 3 levels?
Yes, I saw the 3 levels there. More like
So,
beginner.
Which one do you think? Which one should I assign you to? Except I've assigned you, by the way. You should see a button to be able to join it or something.
Okay, I'm definitely not a beginner.
So
intermediate or advanced.
Okay, so like how will you rate your experience with data structures and algorithms?
Experience in what? Sorry?
With data structures and algorithms.
Data structure and algorithm. Level 2, that is the advanced. I would rate it as advanced if it's open.
All right. I'll throw you there now. So you should see a button to join it or something. I'm not sure how it works. Can you see it?
Yeah, sure.
All right. Have fun. Hi, can you hear me? Hey, can you hear me? If you're trying to speak, your mic is muted. Hi.
Hi.
So we've broken out into groups. Do you know about the groups? Do you know what you belong to?
My data finished, so it took me out.
Oh, okay. What group are you in? Do you remember?
Hopes group 0.
Hopes group. All right. I'll transfer you there now. All right. You should be able to join.
Okay.
Is everybody back here finally? Hope, why you muted? Why is everyone muted?
I think you should close the breakout room so that everybody can return. I mean, time
Some
has
people
really,
ask
really
for some
gone.
people ask for 2 minutes, some people ask for 5 minutes. So let's just give them like 3 minutes, sure.
Time
Let
has
them
gone.
respond.
No.
I know time has gone. We can be gisting while we're waiting for them. Everybody,
Nah,
unmute your
so
speaker. Let's gist. Although
Okay,
I
I
can
have
talk
a question.
something.
I
Like
wanted
to
to
talk.
ask you this question before we
okay.
left that. Yes.
All right.
So now this code, the code I copied, basically the Python code I just that code. Now it does not work. How will I explain this now? How would it work without giving values? Like I need to prompt the user to put in the values or what?
No. Okay, so basically that's why we said you should use lead code. So in lead code, they're taking care of all those ones for you. They're taking care of the worry of you. I mean, they expect that as programmers, definitely I know you would always want to worry about what the input is, where to get inputs, where to get examples, but they've taken all those stress away from you. All they need to tell you is just complete a function. That's what they are bothered about. Complete the function. They have some internal things that are provided the inputs that have provided the all this thing for them. So all they are doing is taking your code and testing it against the inputs that they've already given. So they have the input and they have an expected output that you are supposed to get. So that's why you saw that accepted, success, blah blah blah. So basically it means for each input and the expected output you're supposed to get, once you pass each of them, we call it test cases. So testing against your code, trying to see if your code actually works. If you pass if you pass every single thing, then it means your code actually works at all times. And basically that's what you always want to do. Yeah.
Okay. Thank you.
Yeah, so basically, you guys, while we are still waiting for other people to come back, if you please try and as much as possible to always give a shout out to us, Women Who Code. I mean, just at Women Who Code Lagos on Twitter or on Twitter, just show us your words of um
Appreciation.
whether gratitude, whether pain, whether
Don't
whatever,
insult them
anything we are
outside though.
doing to you.
Insult us here. Don't insult them outside.
Anything you want to say, you can just give us, just tag us at Women Who Code Lagos. Yeah,
Someone
I
asked a
think.
question earlier before I left. Did you answer it?
Yeah.
Okay. What was the question?
Like we ran our code on lead code, I mean, and they didn't see any inputs. Like they didn't see us putting the inputs. They didn't see us. I mean, they just saw that the code just ran and brought some like how
I mean,
manage.
overall, when you're doing the whole goal is for like preparing for interviews, right? And when you're writing interviews, no one is going to ask you to be writing input and all those things. You are just going to define the function that takes something and does something and returns something. No one really cares how you're collecting the input from user, or that's not important in an interview setting, right?
Okay. Okay.
Yeah. So what you just need to do
Yeah.
is your function implementation, what the function is taking in, how it works, and what is returning. So maybe if you want to test by yourself on your own local system, maybe just write a main function that calls it, and you can put in the values you want to call directly. However you choose to call the function is up to you. It's 8:25, so let me end the breakout rooms.
Yeah. So please, if you have not joined the if you have not joined our mailing list, it is very important. It is much more important to join the mailing list than any other thing. Join the mailing list. You can just use this link. Like it's just one question. Just give us your email. Just click on the link and just give us your email address. And please put in correct emails. I have been having issues with incorrect emails and all. So just click on the link and just drop your email. You can even do that now, your phone or something. That's if it doesn't throw you out of this call. But just click and give us your email if you have not, because it is very important that we'll be sharing information and whatever you need to. Just click on it and just give us your email addresses. Yeah, and
Are there any newcomers? Let's shout out to newcomers. Is there anybody that came here that has not come before?
yeah, there are a lot of them. Please
Are they on the Slack
signify
channel?
yourself. You are just coming for today's talk. On mute, say
shy.
something, say
They've
hi.
muted their
Okay, see
speaker.
them, they are raising their hands.
Okay. Well, everybody should be back here now. So hope you can round us off. Me, I'm tired. I want to go and sleep.
Yay. Oh, first timers, wow. Raise your hand again, raise your hand. If today is your first day, like today is the first day you're just joining us, just say hi. I mean, don't worry, we'll hand it over 8:30 before 8:30. Just raise your hands. 1. I saw 2 the other time. 2. Wow. wow. That's nice. I'm impressed.
Those of you that raise your hand, you can go to the back of the church. We're sharing rice.
The ushers will meet you there.
Oh, dear.
Okay, thanks so much, everybody. I just hope you enjoyed the session today. I mean, there's not so much time, but we just want to hope you enjoyed the session today. We just want to hope you liked it. If there's anything you want to say to us, you can always drop a message on Slack. Yeah, very important if you feel you need to say
Sorry,
something
I need to say something.
Yeah.
As I mentioned, guys, please, guys that were in my room, Timile, I think that was in the room. Please make sure you send me a message on Slack. We're unable to go over the optimal solution, so I'll be able to probably maybe tell you guys how to go about it. Because we're very sorry for starting late. That's why we couldn't get to that level, right? So hope we can continue.
We didn't start late. It's you people that did not finish early.
The room I joined started late.
Okay. Sorry for your palavas. You guys should solve it. That's people's business. Sorry. So I mean, time is really gone. Thank you so much, everybody. Please check the chat session. Feel free to say anything to us apart from bad things. I mean, please don't go and disgrace us on Twitter. So on Twitter and Instagram, feel free to say anything good, like anything okay to us. If we have offended you, you can message us on Slack.
This is what 8:29. Okay, is there any feedback before we go? Before we round up, I don't want to hear positive feedback. Does anybody have any
if you are happy,
feedback?
you can.
Did anyone hear me? Oh, did you
Yeah,
hear me?
and very important, please. If you have not joined them, just send the lists. Just send the link to them. Join the mailing list. It is very, very important. There's no WhatsApp group, sorry, but just join the mailing list. Like that is more important. And then for communications and all, we have a Slack group. We'll be sharing the Slack link to everybody on the mail today. Yeah. So any other thing from anybody, you want to say something?
Someone is raising up hand.
Okay. Yeah. Ebele, you can unmute and say something. If you have anything to say, you can unmute just for 1 minute.
Okay.
Say the grace.
I'd like to give a vote of thanks. Okay, someone is talking. Sorry.
It's okay. You can go.
Saying something.
You can go. You can go.
I'd like to give a vote of thanks to the organizers. Oh, okay. Bye.
Okay. I think Chidi can say what he wants to say now.
Okay, Chidi.
Well, I just want to say I really enjoyed the class, and I do want to thank everyone who has actually got in effort to make this stuff a reality. That's just what I want to say.
Oh, thank you. We are touched. Oh, you can say things like that to us on Twitter. We would appreciate. We'll retweet. Thank you. Yeah. So for those waiting for the rice, no problem. We'll attend to you after the service. So thank you.
Bye, guys.
Thank you so much. See you next week. And please come along with your friends and family next week. Thank you. Bye.